Today we are going to learn about prime factorization. So if you want to understand the prime factorization process, you have to learn about prime factor tree. Clear? So what is a prime number? That's a very important. So what is a prime number? If a number has exactly two factors, that is 1 and the number itself as the factors, that number is said to be prime factors. Correct? It's a prime number. So when you express any number as a product of prime numbers, that process is called simply a prime factorization. Here, what is a prime factor? The prime factor of a number are all the numbers that when multiplied together equal the original number. You can find the prime factorization of a number by using a factor tree and dividing the number into small parts. For example, 21, if you consider 21, number 21. So if you divide the 21 as 3 and 7, that is 21 equal to 3 into 7, 3 multiplied by 7. Here 3 and 7 are prime numbers. The number 21 is expressed as a product of two prime numbers which are as prime factors. The process is called prime factorization. Clear? So like when you take any number, you express it into as a product of primes, the process is called prime factorization. As I said previously, a prime number can only be divided by 1 and itself. So it cannot be factorized any further. Every other whole number can be broken down into prime factors. It is like the prime numbers are the basic building blocks of all numbers. So any number is called as a prime factor when a prime factor is a factor of the given number, which is a prime number. Factors are the numbers you multiply together to get another number. Just now I said that is. I will take one more example. For example, if you could take it as 15, the prime factors of 15 are 3 and 5. 3 5s are 15. So 3 and 5 are the prime factors of the number. Let's take some worked examples to understand prime factorization very clear manner. So let's take one number 228. Find the prime factorization of numbers of 228. So there is two steps in this process. One is start by dividing the number by the first number with 2 and continue dividing until you are a remainder. Then divide with 3, then divide with 5, then divide with 7, etc. Until the only number left are prime numbers. We'll observe it. Let's observe this 228. So the smallest prime number is 2, as you know it. When you divide 228 with 2, the quotient is 114. Again, 114 is an even number. How we are going to identify it's an even number? Because the number ended with 4. If a number ended with means the last digit of the number either 0 or 2 or 4 or 6 or 8. That number is said to be as an even number. Even number is a multiple of 2 as you know it, correct? Okay. So 114 is divisible by 2. When 114 is divided by 2, the quotient is 57. But 57 is not an even number because the unit digit of 57 is not either 0 or 2 or 4 or 6 or 8. It is 7. So it is not divisible by 2. After 2, what is the next prime number? 3. So divide with 3. How to identify the number is divisible by 3? Add the digits. 5 and 7. 5 plus 7 is 12. 12 is a multiple of 3. If the sum of the digits are divisible by 3, the number is divisible by 3. So 57 will be divisible. 39, 3 19s are 57. So 57 can be written as 3 of 19. But 19 is a prime number. So when you when you take the process until the last number is a prime number, the prime factorization is over. So prime factorization process is over. Now we can write this division as a product of prime numbers. Now observe it. 228 can be written as 2 of 2 of 3 of 19. See the previous one. So division process. You see the previous division process. 228, 2 of 2 of 3 of 19. So that as a product 2 of 2 of 3 of 19. Correct? So when you express any number, any whole number as a product of primes, the process is called simply prime factorization. So we will observe one more example. Let's find the prime factorization of 189. What you have to do? First you have to divide with 2, then divide with 3, later 5, like the process going on. 189, is it divisible by 2? Very clear. It is not divisible by 2. What is the reason? The last digit of this number is not either 0 or 2 or 4 or 6 or 8. So it's not divisible by 2. Then what you have to do? You have to divide with the 3. 189. 1 plus 8 plus 9, which is 18, which is divisible by 3. So first you have to divide with the 3. So let's take the process. 189 divide with 3. Then we'll get 63. Again divide 63 by 3. 21 will come. Again divide 21 with 3. 7 will come. So the process is completed because you arrived a prime that is 7. So later there is no process of division. So hence we can write it as 189 as 3 of 3 of 3 of 7. If you write the prime factors product which is equal to that given number 189, the process is over. That's called a prime factorization. Clear? Okay. Now we will observe one more things. I will give it as an assignment for you. Do it and perform the twists perfectly. The first one is write the list of prime factors of 36. What you have to do? You have to divide with the first 2, then go for 3. If it is possible, go for 5, like the process has to follow. Prime factorize the number 784. Next one. Okay. Third one is prime factorize the number 1320. And write the list of prime factors 840. Clear? In this manner, you have to write the total prime factors. Are you understand? Good.